Hi all, welcome back to the part 2 of a moving charge in a uniform electric field. At this segment we are going to see charge moving perpendicularly to the field. It's about case 2 and case 3, charge moving parallel to the field. Let us see case 2, charge moving perpendicularly to the field. Looking into this figure, we can see how the electron projected horizontally into a uniform electric field, which is directed upward. The initial speed of the electron is VO, and the position of the electron at time t for Sx and Sy. When the electron enters the electric field, the only force that acts on the electron is electric force. When the electron enters the electric field E, the only force that acts on the electron is electrostatic force, which is Fv equals to Qe. About the deflection of the charges, electron deflected to positive plates, whereas for the positive charge, proton will deflected to negative plates. So when we compare electron and proton in the part of deflection, electron deflected more than proton. Looking into this figure again, when the electron enters the electric field, the electric force is occurred. This causes the electron of mass m to accelerate downwards with an acceleration a. So it is accelerated downwards with ay equals to q naught times electric field strength per unit mass. This is the mass of electron, which is 9.11 times 10 to power of negative 31 kilogram. Since the horizontal component of the velocity of the electron remains unchanged, which is V0, the path of the electron in the uniform electric field is a parabola. You can see beautiful parabolic path. You can determine the acceleration of the electron by using this formula, and the time taken for the electron to cross the field by using this formula. So x here is equals to Sx. After finding the acceleration of the electron and the time taken to cross the field, we can determine the vertical component of the velocity Vy when the electron emerges from the electric field by using this formula, where Uy equals to 0. Ay is the acceleration of the electron, which we got it before. So we can substitute this Ay at this formula. So the vertical component of the velocity Vy equals to negative q naught Ex per unit mass times V0, where x is equals to Sx. Finally, we can find the electron travel with constant velocity v after emerging from the electric field, where v equals to square root of vx square plus vy square, where vx equals to v0. This is another situation when electron is attracted to positive plates, where the electric field is directed vertically upwards. I already put all the possible calculations that you can find out from this figure. Initial speed of electron, horizontal distance, acceleration of electron, vertical velocity, the deflection on leaving the field, or we call it vertical displacement on leaving the field, and finally electron travels with constant velocity after emerging from the electric field. Let us try to attempt these A-level questions. An electron traveling at speed of 1.5 times 10 to power of 7 meter per second enters the space between two parallel metal plates 60 millimeter long. The electric field between the plates is 4.0 times 10 to power of 3 volt per meter. So the questions already gave the initial speed of u0, v0 or ux, any of these, which is 1.5 times 10 to the power of 7 meter per second. The horizontal distance of Sx or x 60 millimeter, and electric field strength or intensity 4.0 times 10 to the power of 3 volt per meter. For section A, sketch the path of the electron in between plates and after emerging from the space between the plates. This is a mind map that you can use to find all the possible values which is written in the question. For the section A, sketch the path of the electron in between plates. You can see how the electrons is deflected to positive plates in the uniform electric field. Followed by section B, find the magnitude and direction of the acceleration of the electron in between the plates. You can pick this formula to solve the problem in section B by substituting all the possible values in the equation or formula to get the acceleration of electron, which is 7.03 times 10 to the power of 14 meter per second square. For section C, calculate the vertical and horizontal components of the electron velocity when it emerges from the space between the plates. Again, from this figure you can find the vertical component, which is Vy, and the horizontal component remains same, Ux, which is equals to 1.5 times 10 to the power of 7 meter per second. At the beginning part of finding the vertical and horizontal component of velocity, we have to find the time taken for the electron cross the field, which is equals to 4.0 times 10 to the power of negative 9 second, and substitute all the possible values into this formula to get the vertical component of velocity, which is equals to 2.81 times 10 to the power of 6 meter per second. The acceleration Ay is positive because the electron of mass m accelerated upwards. Therefore, the vertical component of velocity Vy will be positive. How about horizontal component of velocity? It will remain same, which is equals to 1.5 times 10 to the power of 7 meter per second. And D, the final part of the questions, find the angle of deflection of the electron beam. Simple like a bubble, you just have to use this formula to find the angle of deflection, where tangent theta equals to Vy over Vx, and the angle is 10.6 degree. Let us go to the final part of the case, where charge moving parallel to the field. Figure 1 shows electric force and electric field are in the same direction, whereas in figure 2, electric force and electric field are in opposite direction. From figure 1, positive charge attracted to negative plate, so electric force is in the same direction of electric field. Whereas for figure 2, electron is attracted to positive plate, where the electric force is in the opposite direction to the electric field. So for the case 3a, charge moving parallel to the field, we can find the velocity v of the particle and the displacement s and the acceleration as well by using this formula. For the case 3b, when the parallel plates in the horizontal form, case A in a vertical form, when the plates in a horizontal form, acceleration acting upwards, it will follow the direction of electric force. Whereas for case 3a, the acceleration acting horizontally in the direction of electric force. So it totally differ to the case 3b. So by applying Newton's law 2, we can find the acceleration in a vertical direction, which is stated here. Let us try to attempt these UPS questions year 2013-14 to strengthen up our confidence. A 0.2 gram particle carrying a charge of 3 microcoulomb is placed in a vertical upwards uniform electric field. Roman 1. Sketch the forces acting on the particle. So this is the answer for section B, Roman 1, for the forces acting on the particle for the uniform electric field. How about B, Roman 2? If it is accelerates at 20 meter per second square, calculate the magnitude of electric field. Questions carried 5 marks. This is the solution for B, Roman 2, where the electric force is greater than the weight. The acceleration is acting upwards in the direction of electric force. By using the Newton's law 2, electric force minus weight equals to ma, where electric force equals to Eq. By substitute all the possible values into this formula, we can find the magnitude of electric field, which is equals to 1987 Newton per Coulomb. Thank you for watching this video. Thanks a lot, and thank you to the Lord.